Yo, 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 I'm back. Word up. Grandmaster C here. Mr. Canu and his never ending slackiness asked me to cover for him for this last video of Chapter 14 Aerospace Engineering. Okay, we've covered quite a bit of things, and my buddy Trev Lucas Woo in the last video did his part, but I'm going to go and finish this one up. So, objectives. On this one here, we're going to look at, you'll understand the basics of space flight controls and the challenges of re-entry. You're also going to give examples of aerospace engineering applications. Yo, yo, yo. Back again, because I had to switch to whatever slide we were on. This is just a quick review because, we talked about the design of aircraft. Okay, we looked at the shape of the wings. We looked at the idea of controls. Okay, that's pretty important. We also looked at the idea of structure and materials. And I told you that story about Mustang racing. Now we got to look at astronautics. This is really our last section, so to speak. Okay, so when we look at astronautics, we look at manned and unmanned flight outside the Earth's atmosphere. Okay, whereas everything else underneath was inside the Earth's atmosphere. Now, of course, these are more complicated design considerations. And of course, there is a difference of engineering decisions because it's depending on the kind of spacecraft that's being designed. On the left here, you see the capsule of Gemini 9. After it has splashed down, the astronauts have come out. This is in the year 1966. Okay, Mr. Canu was around at that time, and he certainly had more head on his hair than he does today. Now, the other extent was the idea of using something that would be reusable, a reusable vehicle, which was the space shuttle. Hey, engineering hint, or tip, I should say, or fact, factoid, doesn't matter. The original idea for the shuttle, ladies and gentlemen, the program, they were estimating that they would be able to use the space shuttles for 5 years. And that was it. That was their original intent for the space shuttle. Guess what? 20 years. 20 years it had been part of the space program. And we've done so many cool things with the shuttle. Yeah. Good times, good times. All right. Uh-oh, what is it doing? Okay. Now, there is unmanned spacecraft, like flyby spacecraft. Okay, this is, I believe, the International Space Station from a weird angle. Okay, but these are satellites. Okay, now they can be used for communications. They can be used for satellite telephones, if you've ever heard of those, that as long as you were exposed to the open air with your satellite phone, you could literally call anybody on the earth. Now, of course, that is really expensive, and it's not quite the same thing as the cellular phone service so many of us are accustomed to. Okay, because there's a point with a cell phone service, you are out of the area, you have no communication. But with a satellite phone, you're not relying on a set of towers on the planet. You are relying on a set of satellites up in the atmosphere, up just above the Earth's atmosphere. Okay. Now, of course, other things, spacecraft, there's also the lunar module. Okay. And that's what it looked like. Now, the idea about the lunar module, when they first set on the moon, they were thinking that the lunar lander was going to sink about 12 inches in there because they thought that the surface of the moon would have so much dust. And it turned out to be like about an inch or two. That was it. Okay. Now, on the moon today, the bottom half of the lunar module is still there. This part took off with the 2 astronauts in it. They would join up with their capsule and then start on their descent toward planet Earth. Of course, manned spacecraft, we talked about the space shuttle program. They are orbiters. The program has since been retired. Okay, we do have modern spacecraft Again, now it's designed, built, and operated by governments and private companies. So it's no longer NASA that's out there, but for example, you have the European Space Agency, the ESA. Now, China has its own space agency as well. Okay, Russia has its own space agency as well. So there are now more and more the idea of having craft go out into space and do some exploration. Uh, that's not a completely crazy idea. Whereas, 80 years ago, it was stuff of science fiction. Okay. Today, that is becoming more of a reality. They're talking about Mars and whatnot. I don't know how far we'll get, but it's that fascination with it. I asked the question at the beginning of the chapter, what would we have missed if we didn't have a space program? Well, for one thing, there's a lot of technologies that were developed as part of putting man on the moon that we take advantage of today, like our cell phones. Okay, and I mentioned that earlier in the year. The computing power of the cell phone is much greater than that of the computers that they used to put man on the moon. I'm just saying, okay? A lot of medications, allergy medications, cold medicines, those are developed during that time of the space race. Yeah. Tang, the instant breakfast drink, okay? That was developed for the astronauts as well. But on the other side of the coin, we've also gotten to see the stars and we've been able to see the planets better than 100 miles, than looking through a telescope through 100 miles of air that would mess up the images. With the Hubble Space Telescope, once that got fixed, the images we're getting is just astounding. It's beautiful what is out there. And, when you think God just spoke it and it happened. When God said in Genesis, let there be light. Boom. Just saying. Rockets. Well, of course, we talked about the idea of an engine or vehicle that uses the engine. Now, there are multi-stage rockets that are built in sections. Then there's the Orion multi-purpose crew vehicle, so it can do different things. Space planes. Okay, well, they fly like airplanes inside the Earth's atmosphere, but they fly like spacecraft in space. They have control surfaces like airplanes. The rear rockets provide thrust for the lift and the acceleration. The key thing to look at is getting out of the Earth's gravitational pull. Spacecraft control. We can use rockets for control. Now, there are smaller rockets that can be used for maneuvering purposes as opposed to I'm traveling. Okay, there are main thrusters that are used for liftoff. They can do rotation too. Okay. And again, the direction changes based on direction of escaping gas. So if the escaping gas is blowing this way, the craft is going to move this way. Okay. That's how it works. Newton's third law. For every action, there's an equal and opposite reaction. Now, some people would say, but wait a minute. On Earth, we could do that because there's air for the object to push off of. But you see, in space, you don't have air. You have very few molecules in there. Space is a vacuum, okay? And it is an accurate statement that space sucks. It does. It's a vacuum, okay? So having the spacesuit, it isn't just about sucking in oxygen, or air for us to survive, but it's also a question of protecting us from the heat and cold extremities of space. Because our planet, if we didn't have the atmosphere, on the daylight, we would be baking. And at nighttime, we would be popsicles. In space, when you don't have that air, those temperatures become more of the extreme. That's a real issue. And because it's a vacuum, all right, there's also no pressure. And that causes problems for our bodies as well, okay? Where literally our blood would boil. It just would if we didn't have a spacesuit. And that's not a good thing. But we're not there to talk about the horrors of space. We're here to talk about spacecraft control. Okay? Avionics, as we're winding our way through for avionics, aviation electronics. It's a combination of communications, navigation, flight control, monitoring, weather systems, and tactical electronics. Wait, tactical electronics? Yeah, in a fighter jet or an attack helicopter. When you have warning signs that tell you a missile's coming after you, and it allows you to deploy defensive measures in order to prevent that missile from going up the tailpipe of your engine. Because once it goes up there, it's bye bye birdie. You're done. It go boom and you go boom with it. So that's why you want tactical electronics. Okay. Multiple backups in case the primary systems fail. Redundancy, redundancy, redundancy. Very important. Because if your primary goes out and you don't have a backup, you might have some bigger problems on your hands. Basic needs. Okay, so what about the basic needs that astronauts would need? Circulate oxygen, nitrogen mixture. That would be kind of important. Absorb carbon dioxide. There is such a thing as carbon dioxide poisoning in that your ability to take in oxygen, because there's less and less oxygen, that can cause you to pass out. And if you don't get oxygen in there, yes, you can die from oxygen starvation. That is true. Fuel cells create electricity and drinking water. Because out there in space, yeah, you need those things. The food is similar to frozen dinners. The bathing water is vacuumed out. The trash is expelled and it burns in the atmosphere because it's going through the atmosphere. That it's coming in at a high speed, and because of that, the friction between the trash and the atmosphere, it gets hot. Okay, and trust me, it gets hotter than a Grandmaster C album sale. So it burns up. Working space. Well, yeah, EVAs. You may have heard that in some science fiction films. Special suits for extravehicular activities. It can keep the astronauts alive up to 8 hours. Yeah, the suits inhibit mobility. It makes it a little harder, but the idea is that the EVAs are planned and designed to create the least amount of fatigue. Now, I want to point something out to you. In the early days of space exploration, when we were sending our guys up to the moon, if you look at the old pictures, you'll kind of notice that the astronauts are being helped walk across the launch pad by crew, by the ground crew, where you got a guy on each side of, picking up the astronaut. There's a reason for that. Okay, if the astronaut weighs 130 pounds, the suit is another 200 pounds. So if when the guy puts it on, he's now over 300 pounds. That's kind of tough for him to handle. So that's why they walk them in to the Apollo mission and they put them in the cockpit, the capsule, and all that. Because once they're out in space with the lack of gravity, there's less gravity, it's easier for them to go do that stuff. Okay? So it's kind of important. Re-entry. This is definitely an issue. And as we mentioned before, trash burning on re-entry. Really, spacecraft return to the Earth's atmosphere. Pressure increases around the objects re-entering the atmosphere, okay, and causing temperature increase. Yeah, molecules are rubbing against each other, and that's what causes the temperature increase because they're going so fast. Okay, if you were to take your hands and you were to rub it back and forth as long as you can, you too are going to feel that heat. Now imagine what's happening with the spacecraft that's going in. That's why I included these two pictures here. So you can see, this is how a capsule from one of the Apollo missions would go and re-enter the atmosphere bottom first, okay, because it was specially reinforced to handle that. If you look at the pictures of the space shuttle, you notice the bottom, it's black. How come? Those were the heat shields. They were heat shields tiles, and those tiles were custom fitted. It wasn't like a one size fits all. They were custom. Okay? Now, the purpose of those heat shields is to protect the craft and the crew. And we have to talk a little bit about the Space Shuttle Columbia reentry disaster. What you're seeing there is actual footage of the Columbia breaking up upon re-entering into the atmosphere. What happened? A few of the tiles popped out. I'm not sure where it popped out. The astronauts noticed it when they went on a spacewalk, and they looked and they noticed few of those tiles were missing. Those tiles were the heat shields. Okay. Now they weren't big pieces. The problem is when the shuttle re-enters the atmosphere, that heat, where it's not protected by the heat shield, the heat is going to go in there. And inevitably, what happened was it didn't matter. You had all the other tiles in place. They all had to be in place. The ship broke up. All the astronauts died on that re-entry. And people could see it going across the sky at the time. I didn't see that myself. I was too high. I was too latitude-wise. I was too high up to see it. This is what's left of the shuttle, at least the pieces they found, and they were trying to piece it together. Because the reality was they found the problem, and there was no time to go send another shuttle up there with tiles, extra tiles. There were no extra tiles on board. They didn't stand a chance. They literally didn't. And this was the last major American space disaster that we had. And in earlier years, in 1986, we had the Space Shuttle Enterprise, I think it was, that blew up, just seconds after takeoff. I saw that. I never forgot it. It was unbelievable. And some people, they would think about, well, we should stop. We shouldn't be doing this. In life, there are risks. Everything has a risk in life. And there is an understanding that with those risks, there's going to be concern. And part of the engineering process is to try to minimize those risks. Okay? It didn't work out here. It just didn't. Yeah. But we still go on because we learn from it. We learn from the things that have gone wrong, and we improve on it, and we try to prevent it from the future. That's how we learn. We learn from our mistakes. We all make mistakes, and it's an important thing to learn from those mistakes. The last part, commercial space travel. The reality is, private companies, they're working on it. They're designing, they're building, they're flying spacecraft. Cash prizes are offered by X Prize Foundation. NASA's partnering with private space travel companies. It's becoming a reality now. Of course, they have to sign papers about legal liability and all that other stuff, but wow, the idea of space travel. We're rounding out. Aerospace engineering in action. We do take advantage of it. And one of the things that we can do is having wind farms. Wind farms generate electricity on a large scale. Okay. The wind turbine blade design is similar to the wing and propeller sign of regular aircraft. Okay. And the idea is it would turn the generator and thus generate electricity. And you're not really causing pollution. Unlike burning coal or burning oil in power plants. You don't run the risk of radioactive stuff like in nuclear power plants. So, I mean, there's some pluses here, but there are also weaknesses too. You have to need to understand. But the idea is with the wind turbine blade design similar to the wing and propeller design. Guys, aerospace engineers designed efficient wind turbine blades. And with that, ladies and gentlemen, this actually concludes aeronautical, aerospace, or aeronautical engineering. We've talked about aerospace engineering in action. We talked about the idea of future space travel. We looked at the challenges of re-entry. Okay, talked about how do we work in space with extravehicular activities suits. Okay, EVA suits. What are the basic needs that astronauts have? We looked at avionics. How does that work? Why do we need those? We looked at spacecraft control, how we can use rockets to maneuver. We also looked at the idea of space planes, okay? Dual purpose, fly like a plane inside the Earth's atmosphere, fly like a spacecraft in space. Fly like an eagle. Okay, I'll move on. Okay, we talked about rockets as well. Okay, we looked at manned spacecraft like our space shuttle program. We also looked at unmanned spacecraft, okay, like communication satellites, for example. Okay, we looked at astronautics, looking at those challenges and the awesome aspects of space travel. Okay, and with that, guys, I'm signing off here. I hope this you learned something out of this, and not just because I'm in engineering class and I got to know this material, but it's something to help explain more about the world around us and how did we get to this point here. Okay, because God gave man a mind, an inspiration to reach to the stars and be able to see. There's plenty of space because, again, the heavens declare the glory of God, and the firmament shows his handiwork. Psalm 19:1. All right, guys, I'm signing off. Take care and God bless.